Here are the steps for simplifying a rational expression. The first step is to factor the numerator and denominator completely, and then the second step is to simplify by reducing ratios of common factors. And I have several examples that I'll do with you here. The first one is to simplify x squared plus 7x plus 12 all over x squared plus 3x. So our first step is to factor the numerator and denominator completely. I'll copy the expression here, x squared plus 7x plus 12 over x squared plus 3x. So in order to factor the numerator, it's a trinomial, so I'll create two sets of parentheses for the two factors. And I would think what times what is x squared. That would be x times x. And then what times what is 12. That could be 4 times 3, or 6 times 2, or 12 times 1. 4 and 3 will work because we need a 7x for the middle term. If we make it a positive 4 and a positive 3, we'll get 3x and 4x, which will add up to 7x. And we'll also get a positive 12 from positive 4 times positive 3. So there's the factorization of the numerator. For the denominator, x squared plus 3x, it's just two terms and they have a common factor of x that we can factor out. So factoring out the common factor of x would leave us in parentheses with x plus 3. X times x is x squared, and then x times 3 makes 3x. So the numerator and denominator are now completely factored, and the second step is just to reduce ratios of common factors. The basic idea is that anything divided by itself is 1. So notice here we've got an x plus 3 factor that's common to both the numerator and the denominator. A fraction bar just simply means divided by. So x plus 3 divided by x plus 3, that equals 1, and we can simply cancel those. Okay. So we can reduce the common factor there of x plus 3, and there's no other common factors in the numerator and denominator. So our simplified result here is x plus 4 over x. Here's another example. This one says simplify 5y minus 10 all over 5y squared minus 20. So 5y minus 10 all over 5y squared minus 20. First step is to factor the numerator and denominator completely. So looking at the numerator here, it's just two terms of binomial. They have a common factor of 5. So we can factor out a 5 from both terms in the numerator. In parentheses, that'll leave us with y minus 2, because 5 times y is 5y, and then 5 times negative 2 is negative 10. In the denominator, we also have a binomial with a common factor of 5. So we can factor out a 5 from both terms in the denominator, and in parentheses, that leaves us with y squared minus 4. 4 because 5 times 4 is 20. The denominator is not completely factored because we have a difference of squares. Y squared minus 4 can be factored further. So the numerator is completely factored. We do not have to do anything further in the numerator. I just copied the numerator as is. But in the denominator, we need to factor y squared minus 4 by using the difference of squares factoring concept. So that would factor as y minus 2 times y plus 2. Negative 2 times 2 is negative 4, and the outer product is 2y, the inner product is negative 2y. They cancel each other out. So y minus 2 times y plus 2 is the factorization of y squared minus 4. Everything has been completely factored, so what we need to do is just look for common factors that we can reduce. I see a common factor of 5 in the numerator and denominator that we can reduce there. 5 divided by 5 is 1, so we can cancel out the 5's. And I also see a common factor of y minus 2 in the numerator and denominator. So we can cancel those out. Y minus 2 divided by y minus 2 is also 1. So that leaves us with, in the denominator, y plus 2. And in the numerator, when every factor cancels itself out or reduces, there's always an understood factor of 1 that remains. Every time you divide, for example, 5 by 5, both of those are 1s. And if we reduce the y minus 2's, both of those are factors of 1 as well. So in the numerator, we essentially have 1 times 1, which is 1. Okay. So that rational expression reduces to 1 over y plus 2. Here's another example of simplifying a rational expression. We have 2a cubed minus a squared plus 6a divided by 12a squared minus 6a minus 6. So our first task is to factor the numerator and the denominator completely. I'll begin by doing that. Okay. So looking at the numerator, the first thing that we should always do when trying to factor something is see if there's a common factor. And I noticed that all three of these terms have a common factor of 2 and also a. So we can factor out a 2a from every term in the numerator. That'll leave us with a squared from the first term, and then minus 4a from the second term, plus 3 from the last term. 2a times a squared is 2a cubed, and then 2a times negative 4a is negative 8a squared, and then 2a times 3 is 6a. In the denominator, looking at the three terms, I believe we also have a common factor among these three terms, and it's 6. So let's factor out a 6 from all three terms in the denominator. That becomes 6 times, in parentheses, 2a squared minus a minus 1. To get the numerator and denominator completely factored, we would then need to try to factor the trinomials that we have. So in the numerator, let's copy over the 2a and break open two sets of parentheses for factoring the trinomial. To factor a squared minus 4a plus 3, think what times what would give us the first term there, a squared, and that would be a times a. And then think what times what gives us the last term, 3. That would have to be 3 times 1. To get the middle term of negative 4a, both signs would have to be negative. When multiplying, we would have negative 1a and negative 3a, which will add up to negative 4a. And this also produces the correct sign on the 3. Negative 3 times negative 1 is positive 3. In the denominator then, we've got a 6, and then we need to create two factors, two sets of parentheses. So let's think what times what is 2a squared. That would have to be 2a times a. And then think what times what is 1. That would have to be 1 times 1. To get a negative a for the middle term, we need to put a negative sign in front of the 1 in the second factor to get a negative 2a, and a positive sign in front of the 1 in the first factor to get a positive 1a. A negative 2a and a positive 1a will combine to give us negative a, the proper middle term, and we'll also get the proper sign on the negative 1. Positive 1 times negative 1 is negative 1. Everything is factored completely, so at this stage we can reduce common factors. So looking at what we've got, the a minus 1 common factors here can reduce, and the 2 and the 6 can also reduce. We can think of the 6 as 2 times 3, if this helps you. And then that way we can see that the 2's divide by each other and produce a 1 result, so the 2's can cancel. I don't see any other common factors other than canceling the 2's and the a minus 1's. So for our final result, in simplified form, we'll have a times a minus 3 all over 3 times 2a plus 1. This is an acceptable simplified result, and some people like to distribute for the final answer. So, you might see it expressed like this: a squared minus 3a divided by 6a plus 3. I've missed the parenthesis there. So either with the a distributed and the 3 distributed, or in factored form, either way is considered acceptable for the simplified result on this one.